Okay, so now we're going to move on to basic present value concepts. Present value, a little more difficult to understand sometimes for some people, but effectively it's kind of just a reverse of the future value. So now rather than saying how much is something worth in a certain number of years, I want to say, well, if it grows at this rate, what is the value today? So I'm going backwards effectively rather than forwards like I was before. So so the function here, present value of money equals, and if you look at just kind of the inverse of just kind of flip the function here, is the future value divided by 1 plus the interest rate, annual interest rate, over the compounds per year to the power of compounds per year times number of years. Okay, so for example, for this example here, if I want to have $2,000 at the end of 7 years and my rate of return is 10%, how much do I need to invest a day for that to grow to $2,000 at the end of 7 years? So effectively, I have to do this kind of backwards. So 2,000 I know is what I want the value to be at the end of this time frame. Well, if you remember, for the future value, we started with a value and we would take it times 1.1 to get, how much it was in the future. Similarly, okay, in the same way, I can do this in reverse. I can divide by 1.1 to say what it would have to be on year 7. And I could divide again by 1.1 and again by 1.1 all the way back to figure out the fact that I would need to invest $1,026. So what I could say now is if I put $1,026 in my account, it would be $2,000 7 years from now. I could also say that the present value at a discount rate, and discount rate just because we're doing it in reverse, still an interest rate stated similarly, it's called a discount rate. At a discount rate of 10%, the present value of $2,000 7 years from now is $1,026.32. So that's kind of the step-by-step calculation of it, to show this function, but with the numbers in it. It would look something like this. So I got 2,000, that's my future value, divided by 1 plus 0.1 over 1, I over n, to the power of n times t. Now, same formula, but now that if I want to build a calculator out of this, so I can use it for other calculations rather than just the one that we're working on. Same thing, I'm just referencing them now. So the 2,000 is my future value, 1 plus A16. A16 is my interest rate divided by A23, my compounds per year, raised to the power of A23 compounds per year times A20, and actually that should be A18. None of the numbers are the same, but if I was doing multiple periods during the year, I'd want that to be A18. And you'll see it comes out with the same thing. Now, like the other, there is an Excel function for this too. That function is equals PV. So my rate, again, I'm going to take the interest rate. This is my I over N part of the function, interest rate divided by compounds per year. A number of periods, I want to really do my N times T. So compounds per year times the number of years. A payment, again, we're not dealing with that yet. We'll do that in a future video. A future value is my 2,000. My type, again, we're going to go to the default and say 0, or if it's omitted, for the same dollar amount. And again, because this was positive, this came out negative. If you want that to be positive, you should make this negative. It doesn't really matter which is which, as long as you understand what it is you're doing and what the function is doing. So realize that I could change any of these numbers now, and at least for the ones that are referenced, I could figure out, so say it's 10 years, $5,000, rate of 12%, and let's say it's compounded semi-annually, which means twice per year. That would mean that if I want to have, so now that I've changed this, it means if I want $5,000 10 years from now at an interest rate of 12%, compounded twice per year, I would have to put I would have to invest $1,559, and then at the end of 10 years, I would have $5,000. So the present value is $1,559.02. I notice this didn't change because these aren't references, just typed in, but these two are referenced, so these two would change. And now I can use this for a present value calculator. And that's pretty much it for present value.